Awesome, thank you. So, hello everyone. Again, sorry about the tardiness. I had quite the weekend. It's like, today is my thesis defense, which is a pretty big thing, you know. It's the culmination of like 10 years of work in my case, actually. And the day before, I have like a critical failure on a constitution check, catch a cold. Terrible. And now I have, like the whole weekend, I'm worried about like, you know, having the laryngitis for the friggin' defense. So I'm just gonna amplify my voice so as to save some of it for this afternoon. But yeah, so that's how my weekend went. How was yours? Good? Good. Not bad? Man. So, anyway, what do you know? So if I'm a little less swish than usual, it's because I'm not feeling well. I got this cool pointer though. It clicks the slides and everything. It even has a built-in timer, and it'll buzz you when you're 2 minutes to the end of your presentation, which is cool. Anyway, So just to recap, for Lab 1, you have a choice of performing it either on your own time or during class on Wednesday. It should be perfectly possible for each of you to accomplish both Lab 1 and Lab 2 in the Wednesday session, in my opinion. However, don't take my word for it. Take a look at the labs, go through it, you know, make sure that that's accomplishable. So, so we're going to get into some C programming now. This course, of course, is not just a Unix course. We also are going to try to teach you the best programming language, which is the C programming language. I'm a little bit of like, C is like, you know, I'm a little biased. I think that C is a really, really good language. Despite the fact that it has basically none of the modern conveniences. Of course, the C programming language is a language that was developed about 50 years ago. There is nothing in C that does not need to be there. It is a type language, it is a compact language, and it's like how a good author doesn't waste words, you know? Like, if you're writing, the most important thing for a writer is to not bore the reader by including a bunch of, you know, irrelevant stuff, you know? This is kind of the, this is a little bit like how C works. It's a very compact language. It really doesn't contain anything it doesn't need to. And this is by design. So, we're going to talk a little bit about a number of topics. We're going to, you know, I'm taking the approach here that you guys already have a reasonably good understanding of Python. So a lot of how I introduce C is going to be drawing comparisons with a language that you already know. It's like, here's what you remember from Python, this is how it works in C. Fortunately, Python is a C-based language, so much of what you have already studied with Python will be familiar. It's more like you're going to have to learn how to do a bunch of stuff that you are used to Python making easy for you. You're going to have to learn how to do that with a less, you know, a language that gives you less, shall we say. So, let's warm this up a little bit. So, hardware and software. This is terminology I'm sure all of you already know. Hardware is a collection of physical electronic components that comprise a computer's physical form. Software is a series of instructions stored in a computer's memory that may be executed by sometimes arbitrary software systems. A processor is a group of circuits that implement operations on memory, and these operations are known as instructions or hardware instructions. So, in general, what a CPU is and does is it's a series of circuits that perform arithmetic and logical operations on values stored in memory. A CPU will typically contain a certain type of memory called register memory. Register memory is the only type of memory that the CPU can operate directly on. It doesn't operate directly on the RAM or the ROM, for instance. In order to operate on data, that data must first be loaded into the CPU from whichever piece of memory originates in. And in order to store that data in a form more permanent than the CPU's register memory, we must perform a corresponding store operation to load values back into memory. These types of memory concepts are not irrelevant when you're talking about C programming. So, programming languages can be more or less abstract, depending on how directly they access a system's underlying hardware. So in high-level languages, such as Python and Haskell, an operation may represent many hardware instructions. However, in low-level languages, such as C, an operation represents comparatively few hardware instructions. Different languages are good for different things, and a good developer knows which languages are suited to which applications. So, if you do a for loop in Python, that may correspond to many hundreds of hardware instructions, right? Even like a four-line for loop might correspond to a lot of hardware instructions. In C, you're talking probably tens of instructions rather than hundreds of instructions. This is why C is a much faster language. Because all programs, before they are executed, must be expanded and encoded in the underlying hardware instructions. Otherwise, they can't be executed on hardware. And, everything must be executed on hardware. That's how computers work, right? So, when we have a high-level language like Python, where a small program might expand to several hundred hardware instructions, or indeed a very high-level language like Haskell, where a single function might expand to several thousand. I don't know what the exact ratio is, but it expands quite a lot, Haskell. These languages are necessarily quite slow in comparison to a language that decompresses into fewer instructions. That's why C is so fast. One of my favorite examples that a student gave me once, they did a line-for-line encoding of a vision processing algorithm from Python into C++. Now, C++ is very much like C in that it sits in the middle between a high-level and a low-level language. C++ is what we call a superset of C. So every valid C program is also a valid C++ program. But not all C++ programs are valid C programs, right? So by encoding this library in C++ instead of Python, without having altered the algorithm in any way, the student was able to gain a 5 times speed increase just from using a lower level language. So the question then becomes, so what is this good for? What are the applications where a low-level language would be necessary, required, or desirable? So when you write code that's faster, that speed up is multiplied by the number of times that code is executed. So when you're writing a program, there will be some routines which are executed many more times than others. It makes a lot of sense to optimize said routines in a language like C, rather than leaving them in your native Python or any other high-level language. You can affect you can get very good speed-ups that way. Incidentally, programming languages are not monolithic either. A Python program can use C functions. A C program can use Python functions. It's just a matter of knowing how to integrate these various programs, which is, again, kind of why we bring in the Unix stuff, because that's one way of interfacing programs to other programs. In fact, the bash prompt, the whole point of the thing is to interface programs to other programs. So, good. Any questions so far? Good. So, why learn a low-level language? Applications. Anywhere you're programming close to bare metal, you will probably be programming in C. This includes operating systems, kernels, and the stuff that you'll learn about in CompSci2 GA3, computer architecture. Number 2, optimization. Because they use a small number of hardware instructions per operation, programs written for low-level languages can be very small and run very quickly relative to high-level languages. Some optimizations are not even possible in high-level languages. Pardon me. Another thing that, this is more applicable for, shall we say, embedded systems design or Internet of Things applications, but it turns out that your program size itself can have an impact. So in embedded systems design, one of the things that you're trying to do is minimize the amount of memory that your system requires. The memory required to store instructions is memory that you have to pay for if you're, mass producing these guys or something like that, right? So the less memory you have to put in here, the less your product costs as compared to your competitor, and the more money your company could make on the sale of said product. So these types of optimizations actually matter. A lot of, it's even not as uncommon as you might think to write programs for these types of devices in assembly code, to even step underneath C programming into the most, the closest to the actual CPU that you can get, which is assembly code. So, also knowledge and appreciation for what our programs are doing under the hood will make us better programmers. It is impossible to understand how computers use memory unless you have programmed in C. Because the way that C handles memory management is the way that everybody handles memory management. It's just all that changes is the degree to which the language hides the details from you. That's all that changes. Fundamentally, there is one way to access memory, and that is the way that's encoded in assembly code. Using C, we get as close to assembly code as we can without having to actually write assembly code, which is horribly painful, as I'm sure you're going to find out over the course of your degree program. So, here's just a quick reminder of the von Neumann architecture. Remember that the CPU must load memory and store memory in the memory unit, which is off chip with respect to the CPU. So, let's talk about the C programming language. C evolved from two previous languages, BCPL and B. BCPL is the Basic Combined Programming Language and was developed in 1967 by Martin Richards as a language for writing operating systems and compilers. Ken Thompson modeled many of the features of his B language after their counterparts in BCPL, and in 1970 he used B to create early versions of the Unix operating system at Bell Laboratories, although most of this work did occur in assembly. Basically, they used B for some things. They used assembly for a lot else. Through that work, they saw what they needed in a new language. So they took B and they improved it to create C. C is the successor to B, which is why it's called C. So, Dennis Ritchie at Bell Laboratories created the C language as an evolution of B in the year of our Lord 1972, which means that this year, the C programming language is 50 years old and still in use, which should indicate to you how good the language is. It's not like languages get old and die. Like, nobody really uses COBOL anymore, right? But nobody really uses Fortran except for some, like, very, you'll always be able to find some, like, corner cases, some scientist who's stuck in a closet over in BSD who still programs in Fortran or something like that. But, like, overall, nobody really uses Fortran, nobody really uses COBOL, but despite being 50 years old, C is still used reasonably frequently. C initially became widely known as the development language of the Unix operating system. Many of today's leading operating systems are written in C and or C++. Windows, Linux, OS X, Android, and iOS kernels are all written mostly in C. And again, it's because you can't beat the speed. C is mostly hardware independent. You can find a few pieces of hardware that you don't have a C compiler for, but hardware is a very diverse field with many things going on in it. So, universal applicability to hardware is not necessarily the goal, because you'd spend many lifetimes trying to achieve it. With careful design, it is possible to write C programs that are portable to most computers. And what we mean by being careful is sticking to the C standard libraries primarily. So C has a set of libraries which are of fundamental importance to all operating systems. All operating systems have a version of these standard libraries. The C standard libraries should be thought of with the same reverence that you would look at the holy book of a religion. There has been so much work that's been put into these libraries over the years. They are among the most rock-solid pieces of programming in existence. Many of the Python functions that you are used to working with, all they're doing in the back end is calling C standard library functions. Like the print function, for example, is calling printf. Your input function in Python is calling a couple of things. It's calling printf and then also a function called scanf. So, there we go. So, because of its high performance characteristics, C is still used a lot despite being 50 years old. Portability across many hardware implementations and overall performance lend C to operating system development. Linux, portions of Windows and Android use C. Apple's OS X OS X uses what's called Objective-C, which is derived from C. Basically, if you've programmed in an imperative language, that imperative language is most likely C-derived, as we're going to see in a bit. C is also one of the most popular languages for embedded systems development, which typically are highly memory conservative. Additionally, we have what are called real-time systems. So, real-time systems are mission-critical, quote-unquote, systems, which require very fast response times. Typical examples would be something like the software inside of airplanes, right? If the software inside of an airplane does not respond fast enough, you might lose the ability to fly that plane, And given the high degree of complexity of modern aircraft, it's basically impossible for a pilot to run them unaided by electronics and software these days. Like the manual override is not something you want to engage, right? So, yes, so real-time systems. High-performance languages dramatically increase the feasibility of meeting timing constraints. Like there are some systems where if you don't get a result within fractions of a second, then that's too slow. Another good example would be autonomous vehicles, right? An autonomous vehicle must be able to respond more quickly to traffic and changing traffic conditions than you can. Communication systems, due to the massive quantities of data being routed, optimization becomes crucial. So these are situations where you would be calling the same routines like many, many times per second. So, popularity of C. This is the TIOBE Programming Community Index. Basically, TIOBE is a way of monitoring the popularity of various programming languages based on the number of times people search how to use them. So this is, in theory, a measure of how much this program is being used. I think in practice it's also a measure of how much this program, a particular programming language is being taught in schools. But, be that as it may, you'll notice that the C programming language, and I realize the colors are a little bit not fantastic. Can I improve that by shutting the rest of the lights off, I wonder? Let me just see for a moment, so to speak. There. I mean, that may have improved it a little bit. So, C is this light blue line. So you can see that C has been quite popular. It had a little dip around 2017. And I realize this only goes up to like the end of 2020, but C has been a consistently used and programmed in language for the last 20 years at least. You'll notice that this black line here is Python. Python has increased rapidly over the recent years, probably due to various things. This guy here is C++, so you can see C++ has been, decreasing basically as Python has been on the rise. C# never got terribly popular. Visual Basic is now, relegated to a second-class language. And this guy at the top, this is Java. So Java has taken a pretty steep hit in recent years. But yeah, as of May 2021, C was the world's most popular programming language, at least with respect to the number of people trying to learn it. So, the semantics of the C language are set by the International Standards Organization, ISO, and the International Electrotechnical Commission, IEC. in a series of standards documents. The most recent of which is C17. Basically, it's C followed by the year abbreviated to 2 numerals when the language was released. If you want to read the C standard, www.iso.org/standard/47528.html. There we go. There are many C compilers which are all implementations of the above standard. Only the following 3 compilers are compliant with the specification. So we've got GCC, the GNU compiler collection, which is, it's my expectation that this is the compiler that you will use in this class. LLVM Clang, version 7.0.0, which is done by IBM, and IREWarm, which I'm not sure who makes it, but it's also compliant. So this is how it works, right? An organization will publish a standards document. Other organizations will create implementations of the standard so given. So long as all of the requirements stated in the document are complied with, it is an official C compiler. Incidentally, conspicuous by its absence on this list is the Windows C compiler. So the C compiler used to compile the Windows operating system is not compliant with the C specification, at least not in all things. Now, mostly compliant, yeah, sure, but not completely, which is why if you are a Windows user, it is very important that you figure out what compiler your system is using. If your plan is to use VS Code to write your C programs, and then just submit that without checking to see if it's compliant with GCC, since we're going to be definitely using GCC to grade your work, it is entirely likely that programs you write will not compile under GCC. So, it's very important before you submit anything in this class that you verify that your work compiles under GCC, please. This also applies to Mac users. Mac uses Clang by default. In a batch environment, if you invoke GCC, it will actually give you Clang instead. You can check to see what compiler you're using by checking the version number on GCC by using the -v option from the command line. So, if you've got Clang, you need to figure out how to use GCC instead. And that probably means logging into the server. Yes?
Yes, how to verify, and should we worry about it? Should we still worry about if we use the cross server of my master by the
No, if you're using the Pascal server, Pascal is Linux, like straight up Linux distribution. I think it's some version of Red Hat. So it will be using GCC, absolutely, finally, no question.
We don't need to check it.
You don't need to check it if you're using Pascal. You don't need to check it if you're using any native Linux distribution, so even virtual machines. Any questions? Good. So, let's talk about the C standard library. C is not an object-oriented language. It contains no object-oriented structures. There's no such thing as a class. There's no such thing as an object. This may be like very good news to you, depending on how much you like that particular unit in 1MD3. Because it lacks any kind of object-oriented structures, the fundamental unit of abstraction in C is the function. So, whereas with Python we had a few mechanisms of abstraction on top of functions which allowed us to write more compact programs, In C, the level of abstraction that you have available to you bottoms out at the function. The most commonly used functions are collected into the C standard library, the documentation for which may be found at gnu.org/software libc manual pdf libc.pdf. I'm not giving you that URL just for, shits and giggles. This is an excellent reference if you want to know how a C standard library function works and to know what they are. It is also the purpose of, you'll find that a lot of me teaching you C in this class is me teaching you how standard library functions work. But yeah. Use of these library functions is strongly encouraged. Library functions, especially from venerable libraries, such as stdio, which is your basic input-output library, standard I/O, have had decades of optimization and improvement. Rule 1, if a library function exists, use it. Rule 2, learn Rule 1 quickly, which is a reference to the Karate Kid. So, I'd like to talk about a few C-based languages now, just to give you a flavor for things. So, let's talk about C++. C has been extremely influential in the development of many programming languages, perhaps most obviously C++. C++ was developed by Bjarne Stroustrup at Bell Laboratories. It is an iterative improvement on C, crucially adding support for object-oriented programming, which C doesn't have. The name C++ is derived from the increment operator. In C, if you wish to add 1 to a variable, you do not have to type, x plus equals 1. You can simply write x plus plus. We will be talking about increment operators. Increment operators are not something that Python has, but most languages have it. It's again this silly thing that Python does where it says there should only be one way to do something, which is, obvious nonsense if you know anything about programming, but, be that as it may. So Python decided that x plus plus was redundant if x plus equals 1 exists, so they removed it from a language that would otherwise have the operator. At any rate, C++ is C plus 1. So that's where the name derives from. And incidentally, C#, which is another language, C# right here. I know it's kind of small, but basically it's plus, 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 right? That's been stacked on itself. So C# is actually C++, plus, plus. So they're not terribly creative, the C guys, but they do okay. So object-oriented design adds the object, a new unit of abstraction that allows the combination of data with functions. This increases modularization and facilitates programming principles which allow large programs to still be manageable. We will not be studying C++ in this class. However, you should still know what it is that exists. This class, C++ is reputedly, and I think it deserves this reputation, one of the most difficult programming languages to program in, aside from assembly. It's one of the most difficult programming languages that is a 4th generation programming language. So, because it's difficult to work with, it requires a skilled operator. So if you consider yourself to be a skilled person, learning C++ can, basically secure employment for you with working with a language that nobody else wants to work with. because that's how you get a job. You do things that nobody else wants to do, and people pay you for it. Other C-based languages. Objective-C is an object-oriented language developed in the early 80s and eventually acquired by Apple. Whereas C++ has remained mostly a Windows Linux kind of language. Apple, because Apple is Apple and Apple has to be different, decided to have their own version of C++, basically, which ended up being Objective-C. You know, it's C with objects, Objective-C. C++ kind of it rolls off the tongue a little better. Java is a C++ derived language developed by Sun Microsystems in 1991. It uses the Java virtual machine to extend portability to a simply massive number of highly diverse systems and architectures. It is also the language in which Minecraft has been written. The reason that JavaScript is basically the language of internet scripting is because JavaScript also runs on this virtual machine model. So it manages to interpose a layer between the hardware and software, so it doesn't have to be directly compiled to the hardware level, so long as you've got the virtual machine, you know, standing in between for you, which is good if you're talking about the internet, because the whole point of the internet is to be able to connect together many different computers of many different architectures. So that's kind of the legacy of Java. However, how many people know Java? Learned Java in school? A couple of people? Java is kind of like, we make jokes now about Java being a dead language. Like Java is quickly going the way of COBOL. And, you know, like it's a good enough language, but the problem with Java at this point is that it doesn't do anything that any other language doesn't do better. So really, Java is mostly used by people who have existing code bases in Java that they have to keep up, and Minecraft. So C# is Microsoft's .NET framework which integrates internet connectivity into a framework of both Java and C++. Non-Microsoft implementations of C# also exist, such as these game object scripting in the Unity game engine. C# is a little bit like it's mostly a Microsoft thing, but you know, not exclusively. PHP is an object-oriented open-source scripting language used primarily in internet database and internet database applications. Python, exclamation point, released in 1991, same year as Java, and developed by Guido van Rossum, who declared himself benevolent dictator for life of the Python programming language. Python emphasizes the elimination of surplus syntactic detail and has become a very popular language for introductory programming courses, as I'm sure everybody knows. In addition, JavaScript, the most widely used scripting language, adds dynamic behavior to websites as well as viruses. So, any questions about any of that? Okay. I'll give you guys a minute to read the comic. Cool. Everybody done reading the comic? Okay, good. So, compilers then. So in contrast to Python, and all that we know and love from 1MP3, C is a compiled rather than an interpreted language. The process for creating a C program is as follows. Fortunately, most of these are handled by the compiler itself. So, First things first, you must create the program using editing software. My personal preference is for bare bones plain text editors, such as Get or Emacs. You'll notice throughout this course I make jokes about Emacs being popular when it isn't. It's okay. Anyway, Emacs is written in Lisp, by the way, L-I-S-P. So once you have a C program, the next step is pre-processing, then parsing, assembly, linking, loading, and executing. Steps 2 through 5 here occur inside of the compiler itself. Steps 6 and 7 occur when an executable is invoked for execution. So, editing a C file. C files may be edited using any text editor. Common ones include Notepad or Notepad++ in Windows. Anybody who's running a Windows machine and wants a good text editor that does syntax highlighting, highly recommend Notepad++. Emacs, Gedit, or Vim on Linux. Nano is also acceptable. TextEdit on Macintoshes. Fancier environments, such as Jupyter and VS Code, allow for compilation and execution of C programs within the editor itself, although it also will often try to hide important details from you, like what bloody C compiler it's even actually using. Incidentally, the C kernel for Jupyter is crap. It is not usable, it is not fit for purpose. So I know we used Jupyter for inline MD3, but yeah, it doesn't work with C. Otherwise, like there was a time when I tried creating a course on C programming using Jupyter, and I had to abandon it mid-course because it was just terrible. Anyway, C files are given this .c file extension. There are actually a couple different file extensions that C uses for various stages in this compilation process. .c is a C source code file. .h is a C header file. We'll get into header files. .o is a precompiled output file. Again, we'll get into those. And .a is an archive file. Over the course of this course, we'll learn all about them. So, the following process describes compiling a C program from the command line in a Linux-like environment. Let's examine the following C program. This is the most simple C program. This is the hello world of C. So let's examine the differences between this and Python. Pardon me. So, first line, include stdio.h. This is roughly equivalent to the import statement in Python. What you are doing is you are loading an external library. The difference in C is that C assumes much less than Python in terms of what it starts you off with. Basically, any function at all that's not declared inside of the C function must come from a library file. So contrast this to Python, where you get a whole bunch of functions for free just by loading the Python compiler, right? You get print, you get input, you get max, you get min, you don't get the math library, but that's fine. You get lots and lots and lots of libraries. in programmer speak, we call that the prelude, right? These are the functions that are loaded by default without you having to ask for them. C has no prelude, effectively. If you want a function, you must include the library where that function can be found. You must do this. Make sense? Any questions? Incidentally, question?
What's the full name of STD standard?
Yeah, it stands for Standard Input Output. Printf comes from Standard Input Output.h. So, one of the reasons that C is so much faster and more memory efficient than Python is that it only loads, it loads functions in smaller chunks and has no prelude. Obviously, if you load a big long prelude with all kinds of functions, those functions take up space, right? So you have to put them in memory somewhere. So only loading that which is needed, C saves a lot of memory, right? So, good. So let's talk about int main. You're not used to this because you got, okay. How many people have programmed in something other than Python? A little bit? Most people? So, for those of you who haven't, this is going to be a very important idea. Functions, this is a function, main is a function. Functions have a strictly controlled return type, right? When you declare a function, it must be known what type of value that function produces. In this case, it is an integer. At the end, you can see this return statement where we are returning 0, right? To return something that wasn't 0 might cause problems depending on what you return. It turns out that C is actually pretty loose with its types, but not in the way that Python is. You can't just substitute a string for an integer, right? Like you can in Python. What is meant by integer is essentially numeric value of a fixed bit width, right? So integers in C are 32 bits. Anything that can be expressed using a 32-bit integer can be used as a substitute. For example, if you throw a character in here, it will return the numeric value of that character, right? So it sort of implicitly kicks it back as binary data. So to some extent, the concepts of data types in C are somewhat ephemeral. They're somewhat put there by the user. And it's good to, as long as you stay consistent with the data types, everything works out. But the data types are there mostly for your benefit, not the compiler. The compiler in C is a very fickle creature. It will do what you asked it, no matter whether that makes sense or not. So anyway, when you declare a function, you must declare it with a return type. If you do not want the function to return anything, you declare it with a void type, V-O-I-D. So what is main then? Main is the function which is executed by default as the first function that is invoked whenever you run a C program. Whenever you set a C program running, the very first statement that is executed is the first statement in main. So unlike Python, which groups everything on in Python your execution starts outside of any function, just in indentation level 0, shall we say. In C, everything always starts with main. In fact, you can think of running a C program as invoking the main function of that program. That's what it is. You can pass arguments into a main function, and this return value is then kicked back out to the operating system when this program is terminated. But yeah, does that make sense? Any questions about any of that? Okay, so let's talk about printf. Printf works pretty much the same as the print function in Python, with certain exceptions and limitations. It doesn't do as much for you as print in Python. For example, it does not automatically terminate anything you put in here with a new line character. If you want a new line character to be included in the thing you're printing out, you must include it manually. That's why, there it is. Make sense? Good. So, I would like to, at this time, load up that thing and do it. So. So, I've opened up Nano, which is an in-terminal text editor as opposed to the get it that I usually use. I just wanted to show you guys how it might be that you could use this, for example, on the Pascal server. So, include. It even does syntax highlighting for you. stdio.h int main printf hello world new line character return 0. Ta-da. Save. So, you can barely see that, can you?
Yeah, no. I didn't really see that.
Well, it says return. I'm sorry, but I can't do anything about it. So, one other point that's very important about C programs to note. Every line, which is a statement and not a function declaration, is terminated with a semicolon. Right? A semicolon comes at the end of every line. This is different from Python, which does not require a line terminating character other than the new line character itself. In addition, in C, anything inside of something, be that a function or an if statement or a loop, you designate the beginning of the inside bit with the opening curly brace, there, and you designate the end of the inside bit with a closing curly brace, there. Any questions? So let's execute it. GCC hello.c output name hello. My .c file gets compiled to a file that has no file extension. The fact that it has been highlighted in green means that executable permissions have been enabled on this file. That means that it may be executed. The way that you execute an executable is with // hello prints hello world. Ta-da! our first C function, our first C program. Did it work? Awesome. Cool. Any questions? Comments? Syntax errors? So, to compile a program, we use the following command in bash. gcc simple.c output simple. The -o flag specifies the name of the executable file that you wish to produce. In the absence of a -o argument, GCC will dump the executable file using a generic name a.out. You'll probably see me use it a couple of times in this course. So, first we invoke GCC, the GNU compiler collection. GCC knows we want to interpret the file as a C program because of the file extension. Incidentally, if you're trying to compile a C++ program, use G++, not GCC. Next, we specify the file that is to be compiled. It does not just assume what file you want to compile is, you must provide that as an argument. The -o flag allows us to specify the name of the produced executable file. The produced file is the original program expressed in machine language, also known as object code. Note that this is different from assembly language. The actual code that the executable comprises is known as object code. This is different from assembly code. Although, in theory, an assembly program would be compiled one-to-one into object code instructions. The thing that makes object code different from assembly code is that object code is binary encoded and can be, the binary encoding of object code is the codes for the instructions that the CPU receives. And assembly programs are still encoded in characters so that they're readable by humans. So let's talk about what the compiler does. Once the compiler is invoked, it goes through a couple of stages. The first step is pre-processing. The purpose here is to make the code ready for parsing and generation. So pre-processing does a number of things. It removes comments, it expands macros, it expands any included code, include being the equivalent to import, and it does a few other things as well. Obviously, comments are not meant to be read by the compiler. One of the first things it has to do is remove them. After this, we enter parsing. The code is broken down into tokens, the process being known as tokenization. These tokens are then arranged into a hierarchical abstract syntax tree. The AST is then used to create a series of machine code instructions which are saved in an object file, star.o. This is the assembly stage. We are assembling the object code from the abstract syntax tree. Then we have linking. The object file is linked up with relevant libraries and an executable is produced. So this is how the computer works, right? This is how something like printf gets invoked. The printf function is like the code that constitutes the printf function is never directly copied into your executable, right? What happens is your executable is linked to that library function, right? So the code that constitutes printf is kept elsewhere in your operating system, and a symbolic link, much like an internet link, is created, which basically anywhere your program uses this function, it refers to another place in the operating system where that function exists and dwells, and it uses that code, then it returns to itself its own main line of execution. Does that make sense? So, in blue Blocko vision, this is what it looks like. This is the typical C development environment. We create the program, we pre-process the code, the compiler creates the object code, and then the linker links it with the libraries, creates an executable file, and stores it on the disk. The only thing that you are responsible for as the programmer are the things which I demonstrated on my laptop. Creating the file, compiling it, executing it. However, it is important to know how compilers work. Some of the labs that we're going to do in this course are going to require you to perform partial compilations in order to do things like create your own libraries. So, your invocation of GCC may not end successfully if your code has bugs in it. In general, there are two types of things that you have to worry about with GCC. One is errors, and the other is warnings. You may or may not be used to seeing warnings, depending on, I'm pretty sure Python only complains when it has a direct error. It doesn't complain about warnings. But anyway, so Python is an interpreted language. It doesn't load the whole program at once. It doesn't have the capability to scan through the whole program and find errors before it gets executed. C, you load the whole program into the compiler, and it can be analyzed in its entirety. Therefore, the types of problems that it's possible to find using the C compiler is a larger set of problems than the problems which can be found with Python. That's one of the reasons that Python sucks. So, here are some of the types of errors that you can receive. Syntax errors. Syntax errors are errors that occur during parsing if the code cannot be parsed correctly. That is, have you written your code according to the language C? Is it grammatically correct? Right? If your code is not grammatically correct, then you get a syntax error. Forgetting a semicolon causes a syntax error, for example. Incidentally, that is what it's called. It's called language grammar when you violate, anyway. I happen to be, today I may become a certified expert in computer grammars, so I know what I'm talking about. It is called grammar. Syntax and semantics. The syntax is how the language constructs statements. The semantics is what those statements mean, right? Anyway, so compiler warnings do not halt the execution of the compiler, but they can indicate problems of sort of other types of problems with your code. Some warnings are not shown by default, but if you use WALL, warnings all, then GCC will show you all warnings. Not all warnings are relevant, some are, some aren't. If you don't want to see any warnings, which is not recommended, you can just use the lowercase w flag. By the way, with all of these options, they're all case sensitive, so keep that in mind. These are the types of things that GCC will warn you about. Data types and pointers being used incorrectly. So if you violate a data type, it doesn't cause an error. It causes a warning. So it will still produce an executable. Right? Not using a variable that has been declared produces a warning. It's like, hey, you're declaring memory you're not using. Using a equal sign instead of a double equal sign. Because C is C, if you use an assignment operation inside of an if statement, it will perform assignment inside of the condition of an if statement. That's a thing that it'll do. And it'll only warn you about it. It won't prevent you from doing it with an error. This is the Wild West of programming, folks. So, executing the executable. In a Linux-like environment, an executable is run using the following command. // and then the name of the executable. This invokes the final two steps. Number one, a compiled C program is loaded into the system's primary memory system, normally the RAM. Then the CPU runs the program, starting with the first instruction and proceeding until the program terminates, either reaching the end of main or hitting a return statement inside of main. That is what terminates the program. The thing that terminates a program is the same thing that terminates any other function, because a program running is just the running of the main function. And I forgot to say this, but I remembered, so I'll say it now. So in Python, right, all of your statements are at level 0 indentation, right, for your main execution. What Python is doing there is it's just implicitly wrapping your entire file in int main, open brace, close brace, right? Like, it's doing that implicitly. It's like everything inside of a Python file is, technically speaking, inside of the main function of a C program. Because that's, like, it's not, like, it doesn't quite compile down to C. Like, some languages do just compile to C and then C is executed by GCC. That's not the case, but, you know, close enough, basically. Yeah. Question?
When you load or link, want to link from library files, does it load the entire file or just the function that you're using?
So it loads the entire executable file, right? That executable file will contain symbolic links to other code elsewhere in the operating system. It'll retrieve that as necessary. That's dynamic libraries. But yeah, yeah. C lacks the ability to tell which functions in your file you're using and which ones you aren't, right? If you declare it, it will end up in the executable. If it's used or not used, you know, we're going to actually, we're going to look at some tools that will tell you how often your functions are being used a little later in the course, and, you know, execution counts and that sort of thing when we start getting into benchmarking and profiling. But in general, if you include it in the C program, it will be included in the executable. Does that make sense? Does that answer your question? Cool. Any other questions? These are good questions, even though there was just one question. Anyway, so, executing the executable. The program exists on the disk. The loader loads it into primary memory. Then it interacts, the CPU interacts with the primary memory, taking each instruction, fetch, decode, execute, fetch, decode, execute, fetch, decode, execute. This is like actually CPU's pipeline, so that they're always fetching the next command, they're always executing one minus the next command, and they're always decoding one minus the next command, and they're always executing. It's like, I don't really have time to explain pipelining, but anyway. So, when runtime isn't fun time, often your code will contain bugs, despite being compiled and linked successfully. If it's a problem with the executable, it's a semantic error rather than a syntax error. The difference with Python here is that Python mixes up its syntactic and semantic errors. It won't actually tell you you have a syntax error until it hits one. So like you can have like a syntax error in a branch of an if statement that's never executed and you would never know. Which, like, as a programmer, just makes my skin crawl, you know? So, some semantic errors will just straight up crash your program. These are known as fatal errors. Fatal errors include dividing by 0, trying to access memory that doesn't belong to you, which is known as the segmentation fault. You guys are going to trip many, many segmentation faults in this course, I'm sure. Others will just cause a mismatch between the expected output of the program and its actual output. It is important to know what the expected result of a program is for specific inputs. This is known as a specification. Running a program with specific inputs, looking for a known correct output, is called testing. Test early, test often. If we wish to interact with a C program using a monitor and keyboard, that C program needs to interact with the following: standard input, standard output, and standard error. The standard input stream, standard output stream, and standard error stream. So, if you think back to the unit on file I/O from 1MD3, we talked about this. So, standard input is the place where your computer logs keystrokes for retrieval by other programs. So when you tappy-tap on your keyboard, those button presses correspond to characters being stored in standard input. Your C program may retrieve characters entered via standard input using various standard library functions like Scanf. Standard output is a place which collects things programs wish to print to the screen. So, given that this is a terminal environment, basically standard output is a file where the C program writes characters into that file in the same way that it writes characters into any other file. The operating system periodically looks inside of that file to see if anybody's put anything in there, and if it finds anything in there, it puts it out in whatever the active display is. That's what standard output does. Standard error is similar to standard output, but it is reserved specifically for error messages. This is useful in a number of ways sometimes you want to capture program output and program errors and put them in different places. This allows that to occur with little error and muss and fuss. All three of these streams are either emulated or are connected in a more complex manner in environments such as VS Code, but are used directly in bash-style environments. So in VS Code, at the bottom of the screen, you get this little console that's where your stuff outputs to, right? It's emulating a standard input-output stream rather than, using the base one that the operating system is using. Bash is using the base input-output streams that the operating system uses. Questions? Cool. So, this is the last slide. Then you need to invoke the compiler. And what's a compiler? Well, in this case, a compiler translates source code into object code, which is then passed to a linker, which turns it into machine code. What's machine code? Machine code is the code that can be directly executed by the CPU of what's a CPU? The CPU is a microprocessor what's a microprocessor? 10 minutes later. So the positive charge attracts electrons from p-type silicon that separate what's an electron? 30 minutes later. According to this theory, electroweak symmetry breaks down at about 100 GeV. What's a GeV? I have had this exact conversation with my wife. Yeah. Any questions? The next topic is a little bit beefy, so I'm gonna break the rule about one topic per lecture and get into the next one. So now we should have a pretty good idea of what the bloom and heck C is. The question remains, how do we use it? Good. Question?
On the previous lecture.
Mhm.
Are libraries like standard I/O stored in machine code or in C?
They are stored as pre-compiled object code. So the computer doesn't need to recompile them. Basically, it compiles them into executable format and links to them that way. Does that make sense? Yeah. However, you will be able to find like C code versions, like that you would be able to read as C code somewhere in your operating system. One of the things that happens when you update libraries on your computer is it will recompile these libraries as part of the update process. Does that make sense? Yeah. That's what installation means, basically, is I'm now compiling this software for your system. That's a good question. Any other questions? All right. So let's talk about how you actually bloody program in bloody C then. Blumenek. Yeah. All right. Boom. All right. So this should look familiar. This is our really simple C program. We've already gone through most of it, but there's one point here that's different from, well, there are 2 points that are different versus the previous program. Actually, I feel like the Spanish Inquisition. 3! There are 3 points with this program that are different from the last one we saw. Can anybody tell me what they are?
The comments?
The comments exist, yes. In C, comments are indicated by double slash, double forward slash.
The main function has like a method for it.
Yes, the main is given void as an argument. Sorry? There's no return statement. Very good. These are the 3 differences. Thank you. So, putting void here is syntactically equivalent to just leaving the braces empty, but it indicates this main program does not receive any arguments. This is, you can use this for other functions as well. If you want a function to not receive any arguments, void. If you want the function to not return anything, you put a void here. We can avoid the problem entirely. So, lack of a return statement. C functions, if you reach the end of a C function and no return statement has been indicated, it will return 0 by default. So it's implicitly returning 0 here. You don't have to state it explicitly, but you can if that's, it's recommended that you put it in there, but you don't have to. So, comment your code or else. In C, the octothorpe character designates a single line comment and doesn't really have multi-line comments. In Python, you can do doc strings, which are a way of, commenting multiple lines, but Python is picky about where you can put them. In C, you have access to multi-line comments. /* begins a multi-line comment, and */ ends the multi-line comment. Anything in between those 2 characters is commented out. These asterisks running down the side are not syntactically necessary, but they are pretty. And part of the point of comments is to make the code look nice. So I would recommend inclusion of these asterisks. But it's entirely up to you. We'll be talking about what is and isn't appropriate to comment on when we talk a little bit more about documentation. But here are some guidelines. Things that it's nice to include. At the top of the file, the author of the program, the date of the program's creation, the date of the program's last modification, and the purpose of the program. Comment each function to indicate its purpose. This includes any assumptions about inputs, properties of outputs, and invariants that will hold throughout execution. Comment the end of each function with something like end of function X. This will make it much easier to navigate your code. Particularly, if you're following my recommended advice and using a very simple text editor. A common feature which is included in code editors of a more modern variation is what's called code folding. So you get like a little drop-down arrow wherever you have a function declared, and if you click that, it'll collapse the function definition up into just its first line so that you don't have to, scroll through it every time you want to scroll past it, right? Code folding can be very useful. Many basic text editors do not support such fancy doodads. So, C functions can get quite long, several pages, so it's useful at the end to designate the end of the function that you're in, or that's, it just lets you, see what function you're dealing with from both sides of the function. I think that's useful. So, anything beginning with the octofork character is, in point of fact, a preprocessor directive. These are instructions which are executed by the C preprocessor. This includes include statements, so to speak. So, in Python, we access libraries using import. In C, we use include. Preprocessor directives are processed before the program is parsed. .h files are known as header files. Many of C's most important libraries are stored in header files. stdio that contains the definition for printf, and much more besides. Adding the line include stdio.h to the beginning of each C program should become reflexive. It is unlikely that you will write a single program in this course which does not require that line. If you do not include that line, the program has no way to interact with standard input and standard output, and is thus useless. Any questions? There are other types of things you can have here, which are called macros. We'll talk about macros a bit later on. So, in Python, statement blocks are indicated using indentation. So this is like standard Python syntax for the maximum of 2 integers. This is the same equivalent program in C. Notice int instead of def, right? Also notice that data types must be declared in the arguments. Well, okay, it doesn't technically have to be there. It'll default to integer if you don't include it, but it'll also warn you that you didn't include it. So it'll say, warning, data type unspecified, defaulting to integer, something like that. So, curly braces indicate statement blocks. You'll notice the indentation scheme is the same as in Python, but it turns out that indentation actually doesn't matter in C. It's provided purely for the benefit of the programmer. All C statements are semicolon terminated. So in C, white space doesn't matter. This C program, which declares an integer variable with a value of 17, a Boolean variable with a value of false, checks to see if y is equal to false. If so, return x, otherwise return -1. This C program is identical to this C program. If you were to load this and this into GCC, it would not be able to tell the difference between the two of them. However, we can tell the difference between them. This is nice and neat and good. This is unclean and messy and bad. Notice you can have midline comments though, using the those things. But yeah, notice, assignment statements split across multiple lines, large gaps, multiple curly braces on one line. What Python did is, so C is a language with a long history. Many of the sort of standard ways of writing C code are actually the product of a long history of development where people came to an understanding of what is the most readable way to write programming code, right? They trial and error this out, right? This struck, like the way that this looks pretty, that's the result of trial and error, right? What Python did is it was like, well, this standard but not required way of writing C programs, we're going to force the programmer to use it by loading indentation with semantic content. So that's what they did. And that's how Python came out the way that it did, in the absence of curly braces. Basically, Python implements as law what in C is politeness. Does that make sense? Any questions? Okay, so in Python, execution begins at the first line of the script and terminates on the last line. In C, execution begins at the first line of the main function and terminates either when execution reaches a return statement inside main or when the program reaches the last line of main. A main function is required for compilation. The top level C program must contain a main function, because if it doesn't have one, what are you executing? Nothing, so it's useless. C programs can load other C programs, can form a hierarchy, an inclusion hierarchy, right? Only the top level requires a main function. You can load up a C program that contains just functions, no main function. Load that into your regular C function or your regular C program, and you're off to the races. Trying to put regular statements in the global namespace will result in syntax errors aplenty. You cannot program regular code outside of a function. That's a syntax error. Code goes in functions. We'll talk about other functions in C in excruciating depth in the coming weeks, but since you guys all know Python, you should have a pretty good idea what a function is. So, the int keyword indicates that main returns an integer value. A return value of 0 indicates the program exited normally, i.e. without runtime errors. That is true because that is the way that the operating system expects it. There's nothing intrinsic about returning 0. That means, this is a normally executed program. That's a convention. And that convention can be violated if you want, but it's probably not recommended. That's like many conventions in C. Like the indentation thing is a convention, but violating it is probably not a good idea. That's the sort of the same situation here. So return value of 0 from any program, at least in a Unix-like environment, indicates I executed normally. Any other return value typically indicates the program exited abnormally, especially if the return value is negative. What will normally happen is if a program returns a non-zero value, that's an error code. And if you're a programmer from the 1980s, what you do is you get your big tome-like copy of the C, the specification for whatever program you're using, look up the error code in a table, and then that will tell you something about why the program failed to execute, maybe. These days, most programs carry somewhat more verbose. They'll tell you what happened, usually using standard error. Giving void as an argument indicates that this program is ignoring any past arguments. The void keyword may be omitted. Questions? Yes?
Where would you see the return from name?
Where would you see the return?
Yeah.
Oh, yeah, I'm glad you asked. So it's kind of hidden, right? But, So, let's see here. Where's my program? Okay, so this kind of gets into a little bit of bash scripting, right? When you're writing a bash script, the return value of the previously executed function is stored in a bash variable called question mark. All bash variables are started off with the $sign. So echo $sign question mark gives you the return status of the previously executed command, right? So in this case, I execute hello, it exits with return value 0, there it is, right? If I were to modify the source code and return, for example, -1, compile it, run it, check it. Now, this is interesting. The return value, it's interpreting the return value as a 8-bit unsigned integer. I gave it to it as a 32-bit signed integer. So, that's why we're getting 255 here. But essentially, that's where it comes in. Does that make sense? When you're writing a bash script, if you're bash scripting, this can be extremely useful. For example, there's a bash script that's involved in the autograder for the C programs for this course, right? One of the things that's a rule from 1MD3 that's also a rule here is if your program doesn't compile, it's not worth anything, right? The way we tell to see if your program didn't compile is we execute GCC over your program, right? Check the return status of GCC in bash. If it returns a non-zero return result, then we do not attempt to execute it, right? We just give you nothing. Whereas if your program did successfully compile, then we will execute it and see what the result is. And incidentally, we also, one of the things we also do is check to see, like, we insert assert statements into your program, which, if you fail an assertion, will also return a non-zero exit status. So we're using this same mechanism to check to see if you failed any assertions during testing. So this is pretty important. But yeah, that's where the return value is routed to once the C program terminates. Make sense? Any other questions? Question? No?
No, yeah, later.
Later? Okay. You're like you're my king of question asking. Cool, all right. Please keep coming to class. So, printing strings should be nothing new, but let's go over it anyways. Printf is equivalent to Python's print function. The biggest difference is that printf does not automatically append a new line character to the end of a string. So the following three print statements, from one string to the next, every one of Lisp, will produce this output, right? The only place that it inserts a new line or goes to the next line is when you have hit an explicit new line character and they don't just have to be at the end of the string. Make sense? So, string formatting should also be nothing new, but there are some important differences. In Python, strings are delimited by either double or single quotes. So, hello world with double quotes is defined as hello world as with single quotes and vice versa, right? There is no literal difference, which is, not to pick on Python too much, but I thought that Python said there should be only one way to do anything. In C, single and double quotes have different meanings. Double quotes are strings, single quotes are characters. One character. There is a big difference between characters and strings. Strings are data structures containing characters. Characters are the individual things that the data structure contains. It's like how if you had an array of integers, you do not confuse an array of integers with an integer, right? That's the same distinction. So, let's just talk about a few of the common escape sequences that this should just be a reminder from 193. So, /n is new line, position cursor at the beginning of the next line. /t is tab, horizontal tab, move cursor to the next tab and stop. A is alert, produces a sound or visible alert without changing the current cursor position. Sometimes this would make, old computers have a little buzzer inside them, and if you were to print /a, it would make that little buzzer buzz at you. I don't know, you guys are probably not old enough to remember this, but back in the 90s when you had a computer, and you turned the computer on, it would take about 15 minutes for the computer to actually turn on when you wanted to use it. And you could hear the hard drive sound was very, very audible. It would be like that. Okay. Side note: have you guys heard of Floppotron? No? Okay. After class, search on YouTube for Floppotron, and basically it's a guy who has all kinds of old hardware from the 90s and makes it play music, popular pop songs, on like that. It's really cool. Anyway, in the startup sequence there were 2 beeps and they were both this character. If you want to, since / is used as the escape character for everything else, if you want to actually insert a /, you have to include it as the character that you're escaping. So escape / equals /. And if you want to insert a double quote, you must escape it using \character. Unlike Python, where you could just cleverly use a single quoted string to put a double quote into a string as content, since all strings are required to use the double quote as delimiters, you must escape the double quote in order for it to be placed in the string. Any questions? So, the following program uses the scanf standard library function to read keystrokes from the standard input buffer. So this is taking input. So, we have two integer variables, I1 and I2. Incidentally, in C, variables must be declared in this manner. They must be declared before their use. Pardon me. Printf, enter your first integer. Scanf, %d, address of I1. Second integer, same line, but referencing the other variable. The sum is %d, new line, I1 plus I2. So, there we go. Let's see what this does. Good. Whoa. Oh, I forgot I was mic'd. Oh, my bad. I've got Python in my fingers. All right. So, executing this function. First thing we do, we print off the command, the prompt. It's now waiting for me to enter something and for me to press enter. What this is right here is this is a string, this is a format string. The %d here indicates that I am expecting an integer. Whatever I receive, whatever I put into the command line, it will choose to interpret it as an integer. So, if I enter 21, and then press the return key, the value 21 gets stored at the address indicated as the second argument. Now, this is a little bit complicated because I know I said that pointers was like a thing that we're going to talk about later, but you know, it's a little, it comes in even this early, so you should take as some indication how important it is. The ampersand as a prefix is the address of operator. What that does is it says, I want to provide to this function the location in memory where it is to store its results. So scanf, once it interprets the input as an integer, it will store it in the address indicated, which is the address of I1. And the same goes for I2. So if I enter it again, there we go. The sum is 34. Notice that the %d format tag also allows us to place variable data inside of print statements. It used to be that you could just use your Python and splice it in there and convert it to string, or put a comma and put it as a second argument, and you didn't have to explicitly convert it and all the rest of it. And that's not how things work in the real world. In the real world, you have to designate where in the string that thing is supposed to go. And nothing is assumed. Common usage is not assumed. You can do anything you want with this. This is a very flexible system. That's one of the things about C. It's C is an extraordinarily flexible system. You can do just about anything you can think of in it. Unlike Python, where you can, if you bend over backwards to get away from the fact that Python expects you to do things in particular ways. But yeah, so that's how that works. Any questions about this example? Yes, sir.
Does Scanf include a new line character?
It waits for the new line character being received to indicate that the user is finished entering data. To my knowledge, the new line character itself is not considered part of the format string. Make sense? It's that's how the user indicates that the transmission is complete. Any other questions? Yeah?
According to there are double n, so should number two line? No, sorry. Sorry, I don't know how to describe it.
Yeah, I've included 2 new line characters here, and as you can see,
But there are
I get an extra space. Hmm?
Oh, okay.
Right?
I thought the number should be after the new lines.
Oh, well, if I did that, it would print out right here.
Yes, but why is that?
I'll show you. So if I move these guys to the beginning here, right? Compile, execute. See where it puts it?
Yes. Okay, never mind. Later. No, I don't want to waste the time of the class.
It's the end of class anyway, so. Two plus 2 equals 4. Any other questions? Okie dokie. I think that's it for class today. You may cease the recording. And